Hi everyone. In the last lecture we have seen how we have arrived at the two transistor analogy of your SCR or the thyristor. Now in that section we have arrived at the value of your anode current as IA is equal to alpha 2 Ig plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2, where alpha 1 and alpha 2 are nothing but the current gain. So here our intention is to make alpha 1 plus alpha 2 to approach towards unity. So when it is approaching towards unity, that means your denominator parts approaches 0. That means your anode current IA increases and therefore the device goes into the conduction mode. So now this concept is being explained with the help of the gate triggering circuit. So in the case of gate triggering circuit, what we are trying to do is that we are giving the anode and cathode positive, so that there will be a feeble amount of current which is passing through the system, and that is nothing but the leakage current. So for a present condition, you neglect the value of the current IA because the device has not started into the conduction mode. Now you are trying to give and apply the gate current to the thyristor. So when you're giving a gate current to the thyristor, this Ig is nothing but your base current IB2 to the transistor T2. So that means the transistor T2 gets turned on. Now when this transistor is getting turned on, then it will result in establishment of your cathode current IK. That means the emitter current is established in the system. So when an emitter current is established in the system, then the current gain of your transistor T2, that is alpha 2, starts increasing. Alpha 2 starts increasing, and the base current IB2 causes the existence of collector current IC2. So here we can write this collector current IC2 now comes into existence, and that IC2 is nothing but beta 2 times IB2. Now again this IB2 is again nothing but your IG, and therefore I can write it as IC2 is equal to beta 2 times IG. So this amplified current IC2 will be serving as the base current of your transistor T1. Therefore the transistor T1 also gets into the operation. So with the flow of IB1, the collector current IC1, this particular collector current IC1 can be written as IC1 is equal to beta 1 IB1. Now this IB1 is nothing but your IC2. Therefore this can again be written as beta 1 into IC2. Now we already have an equation for IC2 here, that is nothing but beta 2 Ig. Therefore I can write IC1 is equal to beta 1 beta 2 times Ig. So now the currents IB1 and IC1 leads to the establishment of emitter current IA of your transistor T1, and this will result in the increase in the current gain alpha 1 of your transistor T1. Now the total current, now we can see that the current which is coming over to the base of transistor T2 is nothing but sum of two currents, that is IC2 and IG. Sorry, IC1 and IG. Therefore I can write it as IG plus IC1 is equal to IG plus beta 1 beta 2 IG, which is nothing but IG into 1 plus beta 1 into beta 2. And so this will again result in an increase in the emitter current IE2, that is nothing but your cathode current. So alpha 2 again increases. So as the alpha 2 has increased, that will again result in a regenerative action is going to happen. So now we will be seeing how the regenerative action is happening. So earlier we know that IC2 is nothing but beta 2 times IG. Now in terms of this Ig, what we are having is nothing but the term which is coming from over here. So that is Ig into 1 plus beta 1 plus beta 2. So the new IC2 will be equal to beta 2 into 1 plus beta 1 beta 2 into Ig. Now this IC2 will be again acting as the particular IC2 will be acting as the base current for your transistor T1. So eventually the alpha 1 increases, and at the end what happens is that this alpha 1 plus alpha 2 cumulatively it will be approaching towards unity, and as a result your anode current IA starts increasing and the device goes into the turn on mode. This is how we can explain using the transistor analogy how SCR is operating using the gate triggering method. Now we are going to use the two transistor analogy to explain the operation of thyristor by forward voltage triggering method. So in the case of forward triggering voltage, you are not giving the gate supply, you are just giving your forward voltage across the anode and the cathode of your thyristors. Now when you are giving a forward voltage across the anode and cathode, basically it is going to increase the collector to emitter voltage across the transistors T1 and T2. And this will result in the leakage current at the middle junction of the thyristor, that is junction J2. So in the transistor model we can represent J2 as nothing but these two junctions are nothing but your junction J2. So this junction J2 is nothing but which is going to carry your collector current IC1 and IC2. So therefore that means with the increase in the leakage current IC1 and IC2 are going to increase. So this IC1 and this IC2 starts increasing. With the increase in IC1 and IC2, the emitter currents of both the transistors also increase. So it is because of the avalanche effect. The I1 and I2 starts increasing. When the emitter current starts increasing, that will again result in an increase in alpha 1 and alpha 2 to increase. And this alpha 1 plus alpha 2, alpha 1 plus alpha 2, when it approaches unity, that will lead to a very high increase in the anode current, and we can say that the device has gone into the turn on action. And this is how we are using two transistor analogy to explain the forward voltage triggering method. Now we will be seeing how two transistor analogy can be used for explaining the dV by dt triggering method. So in the dV by dt triggering method, you are trying to give the voltage across the anode and cathode with the gate circuit in the open condition. Therefore, we can write the current I is nothing but Cj into dV by dt, where V is nothing but your anode voltage. So this charging current across the junction J2 is nothing but the collector current IC2 and IC1. So this will again induce emitter current in the transistor T1 and T2 as I1 and I2. So in case the rate of rise of anode voltage is large, the emitter current will be large, and as a result, the emitter current will be large, and as a result, your alpha 1 plus alpha 2 starts increasing, and this approaches to unity, and therefore the current IA starts increasing and the device goes into the turn on mode. And similarly, we can also explain with the same concept of the increase in the collector current, you can again explain temperature triggering and also the light triggering method of turning on the thyristor using the two transistor analogy. Thank you.